Welcome back, mathematicians. In this video, we are going to solve more oblique triangles. Now, to solve an oblique triangle means that we are going to find the lengths of any unknown sides and the measurements of any unknown angles for a triangle. We are going to look at case number 2, which is the side-side angle case. This case is where we are given two sides and the angle opposite one of those known sides. This is referred to the ambiguous case because the known information may result in one triangle, two triangles, or no triangle at all. For the triangles that may result, we will use the law of sines to solve them. So for a triangle with sides A, B, and C, and opposite angles of A, B, and C respectively, we know that the sine of angle A over side A is equal to the sine of angle B over side B, which is equal to the sine of angle C over side C. In this video, for the ambiguous case, we're going to focus on the situation where the information provided does not result in a triangle at all. Before we get to a specific example, I wanted to show why this information results in no triangle. So in this diagram, we would be given angle A, we would be given the corresponding side A, and then we would be given a second side, which we'll call B, and we'll place between angle A and side A. And so the first thing we know is that there exists an altitude for this triangle, and it is from this vertex here, which would be angle C, drop down to side C, making a right angle. We call that altitude H, and because that forms a right triangle, we know that H is equal to B times the sine of angle A. And what's nice is that we know the value of B, or will be given the value of B, and also the value of angle A. We also know that side A, the shortest distance side A could possibly be and still form a triangle, would be equal to H, forming a right triangle. So if the value for side A, it happens to be less than the value for H, which again we know is equal to B times the sine of angle A, then the information provided does not form a triangle, which means that no triangle results. Let's go ahead and use that information to solve the triangle where we are given side A, which is equal to 2, side C, which is equal to 1, and angle C, which is 50 degrees. I'm going to go ahead and draw myself a picture to illustrate what I have. And I am drawing this picture with the assumption that this does form a triangle. So this would be angle C, which is 50 degrees. This would be side C, which is a value of 1. I'm going to place A right here, so that's a value of 2, which means angle A is corresponding to it. And then we have angle C and side C. So here's what we want to know. We want to be able to compare side C to the altitude of this triangle. And I'm going to go ahead and draw the altitude, H. We know H is equal to 2 times the sine of 50 degrees. Now 2 times the sine of 50 degrees gives us an approximate value of about 1.532. And so we need to compare the side value C, which is 1, to 1.532. And what we see is that side C happens to be less than H. And because C is less than the value of H, there is no triangle. Another way to look at it, if you prefer not to use some formulas to memorize, is let's go ahead and presume that there exists a triangle, and let's try to solve for angle A. And what we would use is the law of sines. So it would be sine of angle A over side A, which is 2, is equal to sine of angle C, which is 50 degrees, over side C, which is 1. We would then cross multiply to solve, and what we would get is 1 times the sine of angle A is equal to 2 times the sine of 50 degrees. We would then take the inverse sine of both sides to give us A equals the inverse sine of 2 times the sine of 50 degrees. Now if you type this into your calculator, making sure that your calculator is in degree mode, what you'll find is that you'll be given a domain error. And this is because we know that 2 times the sine of 50 degrees is equal to approximately 1.532. So we would have the inverse sine of approximately 1.532. Well, that is not defined for inverse sine, that value. For inverse sine, that value needs to be between -1 and 1. So as a result, it means that you get a domain error, which tells you that there is no triangle, that this information does not result in a triangle. So regardless of whether you start by finding the altitude of the triangle and comparing side C in this case to the altitude, or presuming that there exists a triangle and trying to solve for angle A, either way, you see that the information provided does not result in a triangle. All right, guys, good luck.